So we're not going to be learning anything super new this afternoon. We're just going to apply what we've done. So I realize that today's been rushed, but I wanted to get ahead so that way if you have any questions going into tomorrow's test, you have time this afternoon to kind of stick around and ask questions. We can practice different things. Okay? So now we're just going to be applying kind of what we did last lesson there to actual real world situations. Okay? So here we have a graph of Nolan jumping on the trampoline. So the graph shows how high his feet are above the ground. Okay? And for this one here, I'm going to ask a lot of questions for you guys to break it down for me. So Nolan's jumping on the trampoline. How long does it take Nolan jumping to become periodic? Okay. So can you tell me that answer? How long does it take Nolan jumping until it becomes a periodic graph? I'm going to grab sine function. Two seconds. Perfect. Okay. So the answer for that is 2 seconds. So the first part here, okay, is 2 seconds. You can see here, it starts to look like the same rhythm right here. And if we go down, that's our 2 seconds. What's happening in this section here? What happens over the first 2 sections? What would you say what's happening in that in those first 2 seconds? Well, then grabbing something so it makes it easier for us going forward. Okay. BU, oops. What's that mean? Right? What's happening in those first 2 seconds, the length increased, but if you just think about it, right, he's just bouncing to get started. He's just getting started in like small bounce, littler bounce, bigger bounce, right? He's just bouncing to get up to speed, right? There's nothing. Okay. Now, one second here. I'll bring that graph down here with me. So, what is the period for his jump? Can someone tell me the period for his jump? Now, someone was nice enough to mark off the period here between this and this. Okay, perfect. It's 2. All right. So the period is 2 seconds. Now, what does that period mean in the context of him jumping? What does the period mean in context of him jumping? One second, I got an email from someone. What does that 2 seconds mean in that period? What does the period mean there? When it starts to be inconsistent, but right. So in this case, if you took a look at here, let's do red. That would be the time from hitting the trampoline to hitting trampoline again, right? Or from here to here would be the time to be at the top of every jump. Or in this case, you could say complete one jump on the trampoline. Does that make sense to everyone? Like the person's jumping on the trampoline. So the context of one period is the length of times it takes to do one jump. Okay? Now it says write the equation of the axis of the, okay, it's asking, what is the axis of the curve? Okay. What's my axis of the curve? Okay. So for this, we need our max and our min. So our max here is 4. Our minimum value is 0.5. So axis of the curve, we're going to be, let me think here. I'm going to add those. Max plus min divided by 2, which equals 4 plus 0.5 divided by 2. 4.5 divided by 2 equals 2.25. Okay. Then last question here is, what is the amplitude for this? Not yet, Riley. So what's the amplitude? But our amplitude is max minus min divided by 2, 4 minus 0.5, so our amplitude is 1.75. What does that mean in terms of our jump? What does that mean in terms of our jump? Farley's going to tell me. Almost. Like he goes, like if we draw our 2.25, right? That's how far he's going up and down, right? From center, right? So does that kind of make sense how we kind of just applied what we learned before into the context of a person jumping on a trampoline? Right? Kind of. It's kind of weird, but all right. So at the amusement park, a math teacher had different students ride 2 Ferris wheels. Okay? Some rode Ferris wheel A, some did Ferris wheel B. Okay? And I made the graphs for each one. I want you to compare these two. All right? So I'm going to do the first one with you, and then I'm going to leave you to do the second one. Okay? So we're just going to compare the different aspects of it. But we're not just going to compare the numbers, we're going to give it context within the numbers. So the first thing I'm going to talk about is the period. Okay, this would be Ferris wheel A, this is Ferris wheel B. So my Ferris wheel, my period, I'm going to take the bottom numbers here, 30 to 70. So 70 minus 30 equals 40. So in context for this one, right, that's a Ferris wheel, it takes 40 seconds to go all, right? It takes 40 seconds to go all the way around the Ferris wheel. Does that make sense to everybody right now? How I got that? And the context to it? Okay. Now your job is to do the same thing over here. Don't type it in chat. Oh, no. Okay, so, Abigail, do you understand how I found the period, first of all? So the length of time between these two spots. So the length of time between this and this, right? So I just picked 30 and 70 because they were close to the bottom. So I'm at the bottom at 30 seconds, if you picture a Ferris wheel, right? At 30 seconds, I'm at the bottom, right? And if we go along this time, I'm traveling this way in my Ferris wheel, right? At 50 seconds, I'm at the top. When I come back down, I'm back at the bottom at 70 seconds. So the period is how long it does the one full rotation. So what I did was I just took the highest number, 70 minus 30, which told me that this area here, the length of time here, was 40. Does that make sense, Abigail? Now?
Yeah, thank you.
No worries. Now you guys do this one for me. Don't tell me the answer right away. But I want you to tell me what the period is and then what the context is for it. Right. So who has the period? Who has the context for it? Type it in chat for me. Abigail, if you're asking me a question about your calculator, I'm going to drive to your house with a brand new calculator. Yeah, it's the same, unfortunately. It's kind of boring. It's 40 and it's 40 seconds to go around. Okay. Now I'm going to do my max. Where's my thing here? What's my max? What's my min? So I'm going to write down my max here. My max number here is, now it looks like we're going up by ones here. So my max number is going to be 13. My minimum number is going to be 1 for Ferris wheel A. What's your max and min in yours? So your bricks out there, Kelly? So what's your max and min for Ferris wheel B? Seven and 1. Do we agree with her? Looks like it, doesn't it? 7 and 1. Perfect. Okay. Now, in context, that would be 12 meters is the highest, and 1 meter lowest. Okay. Now, if we keep going on here, we could talk about axis of a curve, and we could talk about the amplitude, right? So my axis of a curve here would be, I'm going to add these. So I'm going to go 13 plus 1 divided by 2 equals 14 divided by 2 equals 7. Okay? And that in context would be the middle of the Ferris wheel, 7 meters above the ground. And then my amplitude is, I'm going to do the minus now. 13 minus 1 divided by 2 equals 12 divided by 2 equals 6. And my context for that is the radius of the Ferris wheel is 6 meters. Okay, because since I go up 6 and down 6, right? Now, can you guys do your, I'll zoom back up here. What's your max and min? So Dominic said the axis of curve is 4. Okay. And the amplitude is 3. Good. Now you could compare these two, right? And you could actually talk about one being bigger, right? So they both take the same time to go around, but you could say how the maximum, like the height of Ferris wheel A is what, 5 meters taller than Ferris wheel B, right? And you talk about the radius of stuff. So we've kind of taken the graph and give it context of meaning. How do we feel about that out of 5? What I just did. 5 is in a makes sense. 1 is in I have no clue what's going on. Okay. But here's another Ferris wheel section, or this is a water wheel. Okay. Angus is a historical site and has 2 working water wheels. Notice that there's a large spike on the circumference of each wheel. He studies the motion spike, collects the data. Okay, so I want you to go through, and how about if your name starts with the letter A through M, you're going to do water wheel A. Okay, so A through M, and then N through Z are going to do water wheel B. Okay, I want you, I'll zoom in, and let's look at, I'll write down what I want you to look at here. Period, max, min, axis, and what's the last one I'm looking for? Amplitude. And give them meaning. Okay? Oh, it's kind of cheating because the meaning was like the same as the one before. Does anyone want help to go through one of these with me? So press H in chat if you want help to go through one of them. Okay. Which one do you want? You want to do number 2?
Yes.
One sec.
Okay. Let's do number 2. All right.
Let me insert a chart here.
So
1, 2, 3, 4, 5, 6.
So water wheel B, right?
Yeah.
Okay.
So what's our period with this?
Our period looks like oh boy.
Yeah.
Let me just think. So we got 2, 1.
What I would do, Farley,
Yep.
as a cheat, use the numbers that are closest to the x-axis.
Oh, okay.
So pick these spots, right?
Yeah.
So you don't have to search as far. And round, like that one's a little short of that line.
Yep.
That one's a little short of the line. Just put it on the line then.
Okay.
Right? Make it simple for yourself.
Okay, so 7, 16 minus 7, so it's 9. For the
Yeah,
period.
and when you have a graph like this, Farley, you can just count 1, 2, 3,
Okay.
4, 5, 7, 8, 9. But you did exactly right.
Okay.
Right?
So period is 9.
And what's the context in the case of a water wheel?
It's periodic, so it goes up and down.
So how long to make one full rotation?
9.
Make sense? Yeah, no, exactly. But I mean, like 9 seconds to make one full rotation.
Okay.
Perfect. Like, what's our max?
Our max should be 5.5.
Good. And what's that? What would that mean?
That would mean that's the highest point at the wheel would go. Most likely above water.
Good. And what's your min?
That would be minus 0.5.
And what's that in this context is going to be?
The lowest point of the wheel.
Yeah, but also how far under the water?
Yeah, how far under the water?
Right. And this type, the highest point, that's above the water. Oops.
Right, above the water, okay.
And our axis?
Axis, I believe, is it 3?
Not quite.
Not quite.
Remember, add them together, but you're adding a positive and negative, right?
Yep.
So it's going to equal 5 divided by 2.
Okay. Oh,
Which is
so it 2.5.
Yeah.
Oh, okay.
And that would be the...
Yep.
Right?
Yep.
And the amplitude?
Amplitude. I'm not too sure what the amplitude is again.
It's max minus your min.
Oh.
So with that negative, it's going to be 5.5 minus negative 0.5, which is equal 6. Then 6 divided by 2
is 3. Okay.
And that would be the
radius of the water.
The radius of the water wheel.
Okay.
Okay?
Okay. Okay.
Now let me do this one real quick. 1, 2, 3, 4, 5, 6. I do believe that's 6. My max is 3.5. My min is also 0.5. Axis would be 1.5, and my amplitude is 2. How are my answers? Did you guys answers match mine? Or does anyone need to walk through how I got those numbers?
Everything matched except for my amp.
Your amplitude?
Yeah, what I did was 3.5 minus 0.5.
Yeah.
And then, so that's 3.
Yeah.
And then 3 divided by 2 is 1.5. So
yeah. So when you do that, you have to remember it's max minus min, so it's 3.5 minus negative 0.5, which will give you 4.
Oh.
Because a negative and negative become a positive.
Oh, true.
Actually adds together. Go ahead, Abigail.
Okay, so when a thing has like multiple curves, it's whichever closest to the line minus the other bottom of the curve, but when it has one, like the temperature one, it would be like 52 weeks for the period.
Yeah. So if you're looking at my screen right now, I cut off the rest of it, right? See how I made it only have like one curve?
Yeah.
You go from like the middle to the middle, like from start to the end. So like the 2 points you would pick would be the middle and the middle. It's just really convenient when you have multiple curves to pick tops or bottoms. Does that make sense?
Yeah.
Yeah. So you kind of pick the same point, right? What you could do, like if you're really sneaky, if you had this on paper, you could just like draw a line, like draw a horizontal line from the start until it hits the line the second time. Do you understand what I mean? Like if I had a ruler here, for lack of a better term, I put it there. Here's my first, I go up, I go down, then it's back here, right? And I could click there and look at it's 9 right on the dot.
Oh, okay.
Okay, I could do it with this one too, right? So I'm going to put it right on the start part. So it goes up, it goes down, and then it's going to be right there. And I'm going to click right there, and it's 6.
Okay.
Okay. Any other questions from anyone? We're all good? Oh, now the fun time. These are the ones I enjoy. Because I'm giving you information, and I want you to sketch me a graph. Okay? And the sketch just needs to be a sketch. It doesn't need to be perfect. Okay? So I could draw like a little stuff like that. But you have to kind of understand what the information is. Okay?
Yo, dude, this is not good. Look at this. That's like 1 million armored trucks.
Jackson, you got to turn down the video you're watching. So, a boat is floating in the ocean on a wavy day. Okay? At the point where the boat is floating 10 meters, or at the point where the boat is floating, the water is 10 meters deep. So I'm going to start here at 10 meters. That's where we're going to start my guy. Okay? And waves are cresting at the height of 2 meters. Okay? Let me restart my graph. You can't go, here's 0. That's the bottom of the ocean. And here is 10. Now it says my waves are cresting. Another way of cresting is the tallest wave. So the tallest wave is going to go up to 12. What does that mean about the lowest part of the wave? If I in the middle, if I start at 10, if I go up to 12, how low am I going to go? If the highest I get is 10, I start at 10, so I start at 10, I go up to 12, what's the lowest I'm going to go? Does anyone have a guess? Not 2. Think about this as my amplitude. I go up 2, and if I go up 2, I'm also going to go down 2, which is 8. Okay? And these take time to practice. And if waves come every 6 seconds, what's this 6 represent? What part? If waves come every 6 seconds, what's that represent? Is that my max, my min, my axis, my amplitude, or my period? What does that represent? It's my period. Good. So realistically, after 6 seconds, I'm going to have a full wave go through. Now, this is where kind of like, now a full wave doesn't go like this, right? It's got to go up and then down. So I'm going to draw like a line straight across here. Now I know my wave is done at this point, right? So between that time, I got to go up, I got to go down, and then I'm back. Does that make sense of what I just did? I went up, I went down, and then my wave's complete by 6 seconds being passed. Now for 12 seconds, I got to go up, I got to go down again, then I'm back in there. And then again, if I draw 3 waves, it looks like such. If you think about this here is my axis of a curve, right? There's my axis. Here's my period. And this 2 is my amplitude. So kind of understanding how those work kind of help you put together a problem here. How do we feel about that? I expect like lots of 1s and 2s probably. Out of 5, how do we feel about that? All right. Oh, I already had a little bit of lunch, but I'll slow. All right. So here's another one. I want you to, I'll give you a little bit to try to draw this out. A car tire has a radius of 45 centimeters and rotates every 15 seconds. Sketch the graph that results from the situation. So to kind of help you picture this, pretend there's a nail in the tire. Okay. Graph that nail's journey through it. Let's say start your graph. No, I'll see what you guys come up with. I'll give you 3 minutes to kind of plug away at this. Put a D in chat if you're all done and you think you have a good graph. Right. Put a T in chat if you want some more time. All right, so there's actually 4 possible answers for this. Okay. Now my radius is 45. So that's actually my axis of the curve. Okay, that's going to be my middle part. This here is 15 seconds. That's my period. Okay. So I'm going to start this first graph at 45. That's where we're going to start. And I'm going to make marks here every 15 seconds. Now, I have my graph here, 45, so I have to go all the way up. My radius here, I'm going to go all the way up to 90. That's going to go to 0 because it's a tire and lands on the ground. So I got to go like this, boom, 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 and back in 15. Right, if I drew a line right across there. Now, tricky thing, I could have sent the tire down first. I went upwards. This is also correct. Besides me being the worst artist ever. Now, to make you even more confused, I could start it on the ground, on the very ground first, right? As if the tire's on the ground, which would just go up and then down. Or I could start it up top. I'm the worst at steady hand. Yeah. How did we do as a group with that? If you had something that resembled one of these three, put a yes, you got it. Put it like a okay. Let me make up a new question for you. Let's say, these have a whole bunch of these sign questions. Let me take a look at your homework. How many did I give you to draw? I have a feeling this is a little bit of a rich, it's tough today for you guys to make that next leap. There's one question to draw on your homework today. I think I'm good with that. I'll leave you with that. Okay? And we'll come back and do that. Well, one thing I did want to do, that's kind of like the end of that lesson. So one